have an equally exciting next speaker with Kapil Surlaker, who is the leader of the big data team and vice president within LinkedIn's engineering organization. His team builds all the infrastructure, platform, and other related systems that enable AI, data science, and other data products at LinkedIn. And prior to joining LinkedIn, he worked at Kickfire, company acquired by Teradata, network chemistry company acquired by Aruba Networks and Oracle. So he has a long and storied history as a senior leader in product and tech engineering companies. And he's going to share with you about DataHub and the metadata journey at LinkedIn. Please all join me in giving a warm welcome to Kapil Surlaker.
I'm super excited to be here, joining you today from California in the Silicon Valley. So today I'm here to talk about LinkedIn's data ecosystem and especially our metadata journey through a product called DataHub and how it is essential to building a truly next generation data ecosystem. Okay, the slides are showing up. All right. So before I get into the metadata itself, let me give you all a brief overview of LinkedIn's data ecosystem as a whole. So I'm assuming most of you have used LinkedIn, are frequent users, hopefully. And as you can imagine, LinkedIn has hundreds of millions of members and customers today who are accessing the site from their desktop and mobile applications. At the same time, we also have a lot of internal users who are employees of LinkedIn who are using various internal apps that are interacting with data. And all these applications, whether they are on the site or they are internal applications, are hitting a lot of the internal web services, which in turn interact with our data layer. And for example, imagine you're a member, you go to linkedin.com or open your mobile application and you start looking at your feed. Maybe it's time to update your profile, send somebody an email. And all these actions that you take on LinkedIn are generating a ton of data, whether it is getting generated or being read and written from your underlying databases. And at LinkedIn today, we have Oracle, MySQL, and Espresso, which is the largest and distributed homegrown distributed database solution that powers millions of QPS. And all this data, as you're interacting with the site, is being fed into our Kafka clusters, right? And as the databases are changing and you're updating the data in the databases, that is also leading to change data capture events being generated and being pumped into Kafka. From Kafka, all this data then gets ingested into our massive Hadoop clusters, which is an exabyte scale data lake, through our ingestion platform called Apache Goblin, which is where a lot of ML, AI, data science, it's happening on a lot of these Hadoop clusters. And the derived data and the insights that are generated are now fed back, in many cases, to the site through derived data stores and indexes, such as Apache Pinot for OLAP queries, and then Search and Venice graph queries, and so on and so forth. Right? So that really completes, as you can see, the full data loop across LinkedIn. Now let's talk about metadata. And rather than get into these academic definitions of metadata and what it is and what is it, and let me just tell you how our journey first started at LinkedIn many, many years ago. So from the previous slide, if you remember, we have this humongous data lake and data warehouse. And back in the day, it was the data warehouse one was on Teradata. And the first question that your analysts or ML engineers or anybody who's working with that data, the question that they start out asking is, hey, what are the data sets do we even have in our data warehouse? whether it's in Hadoop or Teradata. If they're starting with a particular business problem that they're trying to answer, which data sets are they supposed to use? How do they find those data sets? How do they search and discover? Once they find some data set that maybe matches their English description, what does that schema look like? Who owns those data sets? Which data sets are derived from that particular data sets? And on the flip side, what data sets or data flows maybe do those data sets depend on? And these are all, at one level, fairly basic questions that you ought to be able to answer. And many years ago, we found ourselves in a situation where we really didn't have a system to answer these basic questions for these thousands of users who were using our data lake. And that was our first attempt, which I will call the crawl phase, at building a solution. And as far as attempts go, it was fairly straightforward, right? So we know how to do ETL. Let's run ETL processes to crawl the metadata out of every system that we have, ingest that metadata into a lookup database, and serve that metadata for consumption through an application layer that's built on top of the database. Fairly straightforward architecture. So what this meant is we created a central team, which was fairly small at the time. We began with just 2 or 3 people. And that's what we started with. So this central team of 3 individuals owned ETL pipelines for multiple systems. So they had a pipeline to ingest and crawl metadata from Teradata, bring it into the lookup database, ingest and ETL processes from the various log files, ingest the metadata from our Hadoop infrastructure, ingest the metadata from Kafka. And so as you get the idea, it's pretty much an ETL pipeline for each of the systems that we have. And then you dump all this data in a database, you build a search index on the side to help search through that metadata. And then we had a simple user experience and application on top where people could type in their queries and we show them the results, which data sets are applicable that match their queries. Pretty straightforward. And as far as first attempts go, this was actually pretty successful. For the first time, all the users of our data lake now suddenly had access to all the metadata at their fingertips. And it was a big step. So what didn't work well, right? So we learned a few lessons through this. And if you can see the picture, you see this team of people pulling hard on a rope, which is the tug of war, right? And that picture really sums up the experience of the central team through our first attempt, because they were in a tug of war with every other system that they were pulling metadata from. And we realized that this really was an artifact of the pull-based integration that we had built, which was the central team was responsible for all of these pipelines. They were responsible for maintaining these ETL pipelines, and it was their burden to pull data from each of the systems and keep those pipelines operational and running and fresh. So when anything went wrong, whether it was the problem with the pipeline, or in many cases, the problem simply was that the upstream team changed something. And since they had really no idea of what would break this metadata team, this would be quite fragile. So the central metadata team would be constantly firefighting and solving the challenges that they really were not fully equipped to solve, because the challenges were really created by the upstream teams that they were ingesting the metadata from. The model was also kind of rigid because it was all designed by the central team, and it was hard for them to iterate quickly. Whenever something changed in, say, Kafka, they had to make changes to their metadata representation to make sure that that fit the bill. So we learned from this experience, and we went on to attempt number 2, which I will call the walk phase. And we addressed pretty much all the problems that we had observed in the first iteration. The most important one, so I'll start from the bottom of the slide. And the most important lesson was a pull-based integration in this case was really hard for us to scale. And we inverted the model and we said, hey, push-based system is really the right way to go here. That's going to help us solve these problems. And what that involved means the systems that we are integrating with, they are now responsible for publishing the data to the metadata system in a well publicized format. And the point of integration was Kafka. Every system knows what their metadata looks like. They know how to publish to Kafka. And as long as they are publishing into topic that we have asked them to publish in, all very straightforward. By this time, we had also learned and made the model a lot more extensible. So the metadata model had become a lot more extensible. We could tag on more properties that were not necessarily part of the metadata that the source system stored. So let's say, for example, you had MySQL database, and maybe the MySQL database is not storing the ownership information for those data sets. And that's okay, as long as the MySQL team, when publishing into our Kafka topics, created the events according to our spec, annotated the owner, and then published it correctly, and then we would verify it, and that would be it. And that would be much simpler integration. The other change that we did was we learned from our own service-based infrastructure that we have running throughout LinkedIn. And rather than integrating directly at the database layer, we built a RESTful service that hit the underlying database and search index implementations. And this also helped the metadata to be integrated into other user experiences, if that made sense, right? So you could either go through that application that was built on the service, or if you had an application that you wanted to integrate metadata into, you could go and hit the service directly and ingest the metadata that way. And this really was far, far more successful than our first iteration. And the gray box that you see there on the slide, that was basically the metadata store. And we thought that, hey, this is really the last metadata store that we would need to build. And we actually therefore called it TMS, which stood for the metadata store, because the team building it really thought that there is no more need to build any more metadata stores. It's one metadata store to serve the entire needs of the company. And while that was true to a certain extent, we ran into more operational problems, right? So imagine now you have tons and tons of different teams and systems who are really depending on a central team to run their metadata service for them. And that was hard, right? So we wanted to kind of have the best of both worlds. And by this time, to give you an idea, our metadata had also evolved, and our metadata needs and the use cases had also evolved to be a lot more complex. So imagine, we started talking about discovering data sets, and you go, yes, data set is a well-known entity that we can talk about, and each data set has a name and a schema and an owner. Now that owner also is going to be one of the people that we have at LinkedIn. So now you have per people or persons as another metadata entity. Each of those people has a name, they have a department that they work in, and they own other entities. For example, they may be owning dashboards, right? BI dashboards. So again, you talk about dashboards as an entity. And each dashboard often refers to multiple business metrics. So you have metric as another entity. And then you have models and features. And pretty soon you get the idea that this metadata graph itself is not simple. It's a very complex interdependent graph where there's a lot of information in that graph. So by this time, we had learned the lessons from our second attempt. Our metadata graph had also become a lot more complex. And our next attempt was to say, okay, can we have the best of both worlds? So what worked is to basically say push-based model, an extensible metadata model worked great. but we don't want teams to be depending on a single service, which now becomes a single point of failure. They all have to sort of evolve it at the same time. Anybody wants to make a change to their service, now they have to come to the metadata service, so on and so forth. So let's have best of both worlds. So what we want to have is a distributed ownership model. So each of the teams that own and publish their metadata should be able to move at their own cadence. And on the other hand, they need to be able to deploy their metadata service when they want it. And one of the things that we observed is every metadata service has a few operations that they would need to do for any metadata service, right? So they would need to support CRUD operations, they would need to support search queries, and they would need to support graph queries, right? Maybe others, but these are sort of the minimum. So we built something called the GMA, which is the Generalized Metadata Architecture, which was about saying, hey, can we build or build a framework to help each of the teams build their service using this framework. And that would then integrate automatically into a centralized metadata store. So take this metadata graph, for example, and you have, and if you can't read the details on the slide, that's okay. It's really kind of, you look at the circles and those are your main entities, right? You have users, you have data sets, you have data set groups, and each of those entities are related in some ways to the other entities. Each entity has certain what we would call aspects. So let's say you have data set, they have ownership, schema as aspects. If you think about this, each of these entities could choose to say, hey, you know what? I want to run my own metadata service. I want to serve the data set metadata, ownership, schemas, and I don't want to really coordinate my operations with another team that serves group membership information. That is an independent service. So what we started getting to is really a service-oriented architecture for your metadata, right? And just to kind of make it concrete, what this also means that you have a team that wants to build a metadata service. This lets them build that metadata service, and they get the CRUD, search, graph APIs to begin with in that framework. And they are free to choose a default implementation or choose the document store, choose the search index, choose the graph index that they most desire, and that is appropriate for their service. And one of the main benefits of this architecture was also when they built the metadata service this way, the CRUD operations, so when they changed the metadata operations within that service, that would create metadata audit events, which then can get sucked into the search and the graph processor and update our centralized search and graph index. So this really kind of gave us the best of both worlds, right? So each system is now free to build their own metadata service, and they can deploy and operate their metadata service as they wish. But at the same time, we get a native, out of the box, centralized metadata integration without the central team having to worry about this. And these data sets, they are really coming into our search and graph and the metadata system for us to be able to now serve it. Now, putting this all back together, and I know there's a lot going on this slide, but there's only a really couple important things to pay attention to, which is each service, ultimately, like if you look at the user group service, it has a source of truth database, it emits the change capture events, and the source of that metadata might be in Git, but it really comes through that central event processor. And then we build the search and the graph, and which then gets serviced through that data set service. And this metadata graph also gets exposed and ingested on the Hadoop data lake, where that itself can be used for your analytics and relevance use cases. So you have both the online and offline representations of your metadata graph. To wrap it up, so LinkedIn open sourced DataHub a couple of years ago, and it has gotten rapid adoption in the community. We have a very vibrant community on Slack. We have a monthly town hall that goes on, which is very well attended. So I encourage all of you, those who are interested, check it out on GitHub. And not only the usage, but we would welcome contributors as well. So go ahead and submit your PRs, and we pull requests. We would love to have those. Just to kind of quickly summarize the adoption at LinkedIn, we have a massive adoption with integration with all our major systems, tens of entities, hundreds of different types of metadata, and a wide variety of use cases, right? So we have search and discovery that we started with, obviously, but increasingly, a lot of regulatory compliance, access control, lifecycle management of data sets, data ops, AI DevOps. A lot of use cases now are metadata driven, which really drives a ton of productivity. These are some quick, snapshots that I had, but it might be easier for a lot of you to just check it out online. These are kind of just, basic your user experiences that you would get through DataHub. So you can, go search for a data set and you see this listing of data sets. You can click on the data set itself. You can see who the owners are. You can see what the schemas of the look like, which metrics are derived from this data sets, which data sets depend on it. And you can kind of start to see this graph look, right? And you can navigate the entire graph. You can see, few levels of data set that you depend on, few levels of data set that derive from it, and really traverse that graph, if you will, right? Some key learnings, just to close the talk. I hope everyone sort of heard that. One thing, if there's one thing to take away, push is much, much better than pull. As you are kind of designing your metadata system within your enterprise, keep that in mind. General is much better than specific. As you integrate with your systems, one of the things to remember is you'll always be in that multi-center universe. Data sets are always going to be connected, and entities are always going to be connected with each other. And you want to design that model in a much more generic way as possible. And online is as important as offline. So you want that metadata relationship captured for offline analysis, but it's super important to make sure that the metadata can be served for online consumption as well. Right. And with that, I'm at the end of my talk. Happy to take a couple of questions. And I'm available to be contacted on LinkedIn and Twitter, of course, online for if people have questions later on as well.
Thank you so much, Kapil. Looking into the comments on Hopin, people really appreciated the sharing and learning. And personally speaking, big kudos for open sourcing your work. I know that in my role myself at Grab, we're looking at metadata stores right now. So it's just on a personal level, very relevant what you're doing. So I love listening to your journey. So with that, unfortunately, we don't have any opportunity right now to be able to take audience questions since they're not in this Zoom here right now. But again, thank you very much for joining us early California time, and for the great presentation and sharing of your learnings. And again, like big kudos for open sourcing your work. I'm sure it was quite a lot of work to get like the whole organization behind that. But it's very, very much appreciated. So thank you so much, Kapil, for joining us today.
Thank you, Philip. Thank you for having me here.